The process of neurotransmission begins when a neuron membrane's uniform charge is negative 70 millivolts, which is this part here. When conditions are right, the neuron will reach a charge above negative 55 millivolts, passing its threshold, depolarizing, and it is at this point when action potential will fire and transmit its signal to the next neuron down the axon. Neurotransmitters affect the likelihood of an action potential to happen. Excitatory neurotransmitters like acetylcholine increase charge and help depolarization. Inhibitory decrease charge and prevent depolarization, and adenosine is one of these. These are released into the synaptic gap by synaptic vesicles following the firing of an action potential in the nerve terminal. In the synaptic gap, neurotransmitters bind to receptors, opening or closing ion channels, which alters neurons' uniform charge. Caffeine binds to adenosine receptors, blocking adenosine from transmitting to the next neuron. Adenosine is the neurotransmitter responsible for tiredness. Therefore, blocking it prevents tiredness. Caffeine and adenosine primarily affect the lateral prefrontal cortex, the default mode network, the visual cortex, and the motor network. Reuptake is the absorption of neurotransmitters by the neuron that released them. This occurs through a reuptake protein and is only done when an action potential does not reach the next neuron. At that point, it will be reabsorbed. Thanks for listening to our neuron presentation, and that's all.
Neurotransmitter release, binding, and reuptake are critical steps in the neural communication, and here's a breakdown of each of them. So release is when an action potential travels down a neuron and reaches the axon terminal. It causes voltage-gated calcium channels to open. Calcium ions flow into the neuron, which triggers the fusion of the neurotransmitter-filled vessels with presynaptic membrane. This fusion releases neurotransmitters into the synaptic cleft. The second one is binding. Once released, neurotransmitters diffuse across the synaptic cleft and bind to specific receptors on the photosynaptic neuron. The binding can lead to various effects such as opening of an ion channel, which can either excite or inhibit the postsynaptic neuron, depending on the type of neurotransmitter and receptor involved. And the third is reuptake. After neurotransmitters have bound to receptors, their action is terminated through reuptake. This process involves the neurotransmitters being taken back into the presynaptic neuron through transport proteins. Once inside, they can be repackaged into vessels or broken down by enzymes. This cycle, release, binding, and reuptake, is essential for maintaining proper signaling between neurons. Thank you.